Hey everyone. So, have you ever wondered how a computer can learn to be a grandmaster at a game like Go? Or how a robot can figure out how to walk, all by itself, without someone programming every little movement? Well, that's the magic of reinforcement learning. And if you've got an exam on this coming up, you are in exactly the right place. We're going to break down all the core ideas you absolutely need to know. Let's jump right in.
So, this right here is the big question, isn't it? How can an AI learn to master a complex game without a human feeding it a giant book of strategies? The answer is reinforcement learning, or RL for short. The key idea is this. Instead of being taught, the machine learns by doing. It learns from the consequences of its own actions, through pure trial and error.
Okay, so at the very heart of all of this is a really simple but incredibly powerful loop. You've got an agent. That's our learner, our little AI. It exists inside an environment, which is basically its world or the game it's playing. The agent tries something, it performs an action, and in response, the environment gives it back two things: a new state, which is just an update on what the world looks like now, and a reward, which is like a point score telling the agent, hey, that was a good move, or oof, maybe don't do that again.
Now, for a computer to actually learn from this loop, we need to give it some structure. We need a formal set of rules for the game. And in the world of RL, that framework is called the Markov Decision Process, or MDP. I know, it sounds super academic and complicated, but don't let the name scare you. It's really just the language we use to describe the problem our agent is trying to solve.
First up in our rulebook is the state, which we usually just write as a lowercase s. You can just think of this as a snapshot of the world at one specific moment. If our agent is playing chess, the state is the exact position of every single piece on the board. That's it. Simple as that.
Right. So if you have a state, you need to be able to do something. And that brings us to actions, which we note with an A. These are just all the possible moves the agent can make. For an agent on a simple grid, its actions might be moving up, down, left, or right. Pretty straightforward.
And now we get to maybe the most important part, the reward, or R. This is the feedback signal that drives all the learning. After every single action, the environment gives the agent a reward. A positive number for a good move, like capturing a piece in chess, a negative number for a bad move, like walking into a wall. And the agent's one and only goal in its entire existence is to get the highest possible total score.
So, the agent is in a state, it knows the possible actions. How does it actually choose which one to take? Well, that's its policy, represented by the Greek letter pi. The policy is the agent's brain. It's the strategy guide it develops over time. The whole point of reinforcement learning, the whole game, is for the agent to figure out the optimal policy, the one that will get it the most reward in the long run.
So we've got the pieces of the puzzle, but what's the end game here? It's not just about getting the next immediate reward. A smart agent doesn't just think one step ahead. It's a long-term planner. The real goal is to maximize the cumulative reward, the total score over its entire lifetime.
And that brings us to this key formula for something called the value function, V of S. It just means, what's the total future reward I can expect to get if I start in this state S? But look closely at that little gamma symbol. That's the discount factor. It's a number between 0 and 1, and its job is to make rewards now a little more valuable than rewards way off in the future. It basically makes the agent a tiny bit impatient, which is good. It encourages it to find the goal efficiently, instead of wandering around forever.
Okay, this is a super important distinction for your exam. We have two ways to measure goodness. There's the state value, V of S, which tells you how good it is to be in a certain place. It's like knowing that San Diego is a great city. Then you have the action value, Q of S, A, which tells you how good it is to take a specific action from a certain place. It's like knowing the best highway to take from Los Angeles to get to San Diego. See the difference? The Q value is way more useful because it tells you exactly what to do.
And that idea leads us perfectly into one of the most fundamental algorithms in all of reinforcement learning, Q-learning. If our goal is to find the best Q values for everything, then Q-learning is the recipe for doing just that. It's a method that lets the agent build its own perfect strategy guide from scratch just by exploring its environment.
To see how this works, let's look at this super simple grid world. Our little agent can move from square to square. The goal is that star, which gives a huge reward of plus 100. Every other move just gives a reward of 0. So the agent's job is to figure out the best path to get to that star.
All right, deep breath. This is the engine of Q-learning. I know the formula looks a bit intense, but let's just walk through what it's saying.
It tells us how to update our Q value for taking a certain action in a certain state. All it says is, the new Q value is the immediate reward we just got plus the discounted value of the best possible move we can make from the next state we end up in. That's it.
Okay, let's make this real. Imagine our agent is in state S1. It looks at its options and decides to take the action move right. This action gives it an immediate reward of 0 because it's not the goal state, and it lands it in a new state, S2. Now, this is where the learning happens.
So let's follow the recipe from that formula. The agent got an immediate reward, which was 0. No big deal. But then, it looks ahead from its new spot, S2, and it peeks at the Q values for all the moves it could make from there. It sees that the best move has a value of 100. So it takes that future value, discounts it, let's say our gamma is 0.9, and adds it to the immediate reward. So 0 plus 0.9 times 100 is 90. The agent just learned that moving right from S1 is a really good idea because it leads somewhere that's close to a big payoff.
This whole process of taking a step, seeing what happens, and then updating your old estimate with a slightly better new one is an absolutely brilliant idea. And it has a special name that you definitely need to remember for your exam: temporal difference learning.
So what is temporal difference learning, or TD learning? The temporal difference is just the difference between your prediction before you made a move and your slightly better, more informed prediction after you made the move. Q-learning uses this little air signal to constantly nudge its estimates in the right direction. It's basically learning from a one-step-ahead forecast.
And this is why TD learning is such a game changer. The agent doesn't have to play an entire game, win or lose, and then try to figure out what went right or wrong. No way. With TD learning, it gets feedback and improves its strategy after every single move. This makes learning so much faster and more efficient.
Okay, we have covered a ton of ground. So let's boil it all down to the absolute essentials. If you're cramming for an exam, this next slide is your new best friend. This is your cheat sheet.
All right, quick recap. The policy, that's the agent's brain, its strategy. The goal is to get the most long-term reward possible. Q-learning, that's our recipe for figuring out the value of actions. Temporal difference, that's the core idea of learning from every single step. And finally, the update rule. That's the mathematical engine that drives the whole thing. Got it?
So everything we've talked about works great in a nice, predictable world. But what happens when the environment gets a little messy? What if it's random? What if you take an action and you're not 100% sure what's going to happen? That opens up a whole new can of worms, and it's one of the biggest challenges in RL. But that's a story for another time. For now, you have the foundations. Good luck with the exam.